Hello everyone. Today we are going to discuss the problem minimum as reversal so every node is reachable. So let's understand the problem first. There is a simple directed graph with n nodes labeled from 0 to n minus 1 and the graph would form a tree. If its edges were bidirectional, you are given an integer n and a 2D integer array as s, where as I denote that the s between ui and vi represented the directed s. So the s reversal changes the direction of the s and the directed s from u to v is now becomes from v to u. And we having for every node I, your our task is to independently calculate the minimum number of edge reversal required. It is possible to reach any other node starting from I. So we have to return our answer I array, which return the minimum number of edge reversal required for any given node I. So let's understand the problem first more deeply. So what is the problem? What is problem saying? Like this is an directed graph, and we have to calculate independently for every node how many edge reversals are required to travel the whole graph from a single node. So let us say from we are starting from the node zero. So how many node reversals are needed? As reversals are needed to from this node zero, we traverse all the whole graph. So if we are at zero, so we can't move to edge to with this with this direction graph. So I can reverse the edge. So what I do, I just reverse this edge and I reach to 2. From 2, I can go to 1, and from 1, I can go to 3. So, by reversing a single edge, I can say that I will traverse the whole graph, right? And then from 2, I do the same. Whether I can go to 0, yes. Whether can go to 1, from 1, I can go to 3. So, for 2, it's the total number of edge reversals needed are 0. And we are at 1. So, from 1, we can go to 3. And from 1, can we go to 2? No. So the number of edge reversals required is only one, which is noted by this. So only one is used. So now we are at S3. So for from 3, we can go to one node. So one edge reversal is needed here. Yeah. And from 1, can we go to 2? No. So one more edge reversal is needed here. We are finding. I am finding the no edge reversals independently, right? So for this, the reversals are 2. So I have to just return an array the in which is denoted with the answer is independently uh, decided how many edge reversals are required for a given node to traverse the whole graph. So let's what can we do in this? We can just pick any vertex. Like I pick here zero, you can pick two, one, or any one. So I start with zero. Like I start with zero, and I do a DSS. So if I can't able to do means from any given node I can't able to reach any other node. So what specifically I do? So for this for dividing the problem, I'm just maintaining a whole subgraph, whole undirected graph for this. So this is giving me undirected graph. I break this to undirected graph, right? And on this, so yeah, I break this to undirected graph. And now what I store like from two to I store all the edges in a pair of net. So I know from two to zero is an edge, right? So now I don't do with this graph. I don't need this graph. I just mark all the nodes in the map, which is showing that uh, from which node there will be a directed edge to this node. So let us say we are at this node here. So from this node I can go to 2, and I check whether 0 2 is an edge. No. So in this case I have to just increase my DP of that node, right? I have to increment my DP of that node by plus 1, right? I increment my deposit on but then I go to 2. And from 2 I can go to 3. From 3 I can go to 4. And I check there is an S from 2 to 1. Yeah, there is an S. And from there is an S from 1 to 3. Yes, there is an S. Right. I recursively store all the nodes, all the values in DP of I. So what I do, I check, increment my DP of I by 1, right? Increment my DP of I by 1. If I found that the given to be not present in my map, right? So if I done this, I just make a recursive call from from I am at I, so I make a recursive call for its adjacent. So I'm writing adjacent, so I make a adjacent for a recursive call for its adjacent, right? And then I just needed to store the adjacent value. So because if I am at one, and then there is a possibility that any node is not reachable from that point also. So like uh, if there will be this type of directed like if there is not like this, there is this way. So from 2, I also need to direct 1 h. So my answer for this is 1. So this will also contribute to my this answer. So that's why I'm just incrementing that node's TP value with all its adjacent nodes value, adjacent node. So all from U to V. If I write UV here, this will be I think the more clear. So I just change this to so I can write this as U, and I know my U, current U, and this is V. Because I have to also increment my DP of U with the adjacent values, the DP value of adjacent U. And here I am also have to call for DP of V. So I have to call for DP of V only. Right. Here I store all the values in my DP that how many nodes I have to reverse from a given node. Right. So so now my DP array is filled with the values. Now I just encounter with an another like a problem like if I am at 0 and there will be an S from 0 to 1. Right. There will be a S from 0 to 1. So when I calculate the value for 1, then I know dp of 1 is equals to dp of 0 because there is only one edge difference, right? So dp of 0, and then I have to calculate whether this edge is like directive as it's directed from 1 to 0 or from 0 to 1. So for this, I have to just uh, add the frequency if the my let us say this is u to be if there is an s there is an there is if there is no s from u to v. So if there is no s from u to v to v to u, then I have to increment my value by 1. And if there is a no s from v, there will be possibility like there is the s is like from 1 to 2, 0. So in that case, there is an extra one is calculated for that 0. So I have to also reduce that one only. So I have to check from is whether there is then if there is not an s from u to u. This is not an s. So in that case also, I have to reduce one minus one here because I have to reduce that. So this will finally give me the answer. So let's so the code, and I will tell you how the things work out there. So yeah. So firstly, I take I take DP and my map globally, which I can store in all other DFS calls outside. So for that, for the assets, I store U and V in my graph, and I store the graph like a undirected graph, right? And I store the edges from U to V in actual assets because I know these are actual. And from V to U, I am hypothetically, but just assuming that for the sake of calculating the answer. And then I calculate the answer. You can use any node here. I use zero. So I make a recursive call from zero. And it's, let's see the function model. So this is the DFS. So this is the function model. So DFS and I take the input as node and parent and the graph, and I check adjacent address from that node, and this condition is basically for not encountering any visited node. So if parent is not equals to the current node, then I'm checking if is this an actual edge from parent to node, node to parent, node to the adjacent. If it is zero, like it's not an actual is, then I have to increment my DP of node with value one, and then I make a recursive call for that child only. And I also know that after the child calculates its DP value, then I have to also increment my DP value because uh, there is if I'm traveling to any adjacent node, there will be possibility that it's also taking some as reversals for traveling the further graph. So for that, I'm just implementing DP of node with the DP of itinerary. Now I'm done with my there are values stored in my DP. Now I have to calculate for other vertices on. So for that, I just calculate answer for all the adjacent nodes of zero because I showed you like here only that if there is an S from U to V, then I have to there is only one S between two S and vertex. So this S will play the role for either I add minus one or plus one at that case. If it is an actual S from U to V, if there is no edge and we assume that there is an edge, then at that case I have to add minus one. And if there is no edge from V to U, then in that case also I have to add a one, right? For that, and what I do, I store DP of node. I know DP what is the node DP value is equal to parent DP of parent value. DP of the current node value is equal to DP of parent value. But I'm just reducing if there is the from parent to node is a hypothetical that I assume is if it is this if I assume a hypothetical s, then I have to just increment this value by one, minus one, and if there is no edge between node and parent, then at that case also I have to just increment my answer by one. So then I will just couple of recursive calls for every addition. Then all the values are stored in the DP. So finally, I return my DP, and I hope this problem is clear to you all. And you can think about it, how that like how us we calculate for every node the DP values for every node. Now how this from this root node to any adjacent node, how this root node affecting if this the actual 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 edge is like this or this. So how you can think about that, and I hope you will clear this. So I hope you all enjoy this problem and understand this as well. So thank you. For more such videos, like and subscribe to our channel. So thank you.